The pure play foundry model controls the modern world because before it existed, tech companies had to build their own billion-dollar factories just to make microchips. Take a modern giant like Apple, designing the processor for a new smartphone. They focus entirely on the digital architecture of the chip. They don't own a single piece of physical manufacturing equipment. Instead, they send those weightless digital blueprints across the world to a dedicated manufacturer that never designs its own products, the pure play foundry. Why the separation? Because carving microscopic circuits requires extreme precision, using $200 million machines the size of a bus. It's just too impossibly expensive for individual brands. By absorbing that immense manufacturing burden for everyone, one specific manufacturer inadvertently became the physical funnel for global innovation, TSMC. This single business model centralized over 90% of the world's most advanced logic chips, locking the entire physical supply chain onto one self-governed island. So today, when you tap the screen of your smartphone, the silicon brain powering it was almost certainly forged in Taiwan.
This iridescent disk is a silicon wafer, a fragile, microscopic landscape that serves as the physical foundation for the modern economy. Producing these wafers requires a level of precision that pushes the limits of physics. They are manufactured in clean rooms, where workers in hazard suits protect the silicon from even a single speck of dust, which could ruin millions of dollars in hardware. Because these chips are integrated into everything from hospital equipment to global logistics, a disruption in supply is felt within days. Markets react, military systems lose their readiness, and after 1 week of interrupted supply, manufacturing lines for automobiles and consumer electronics begin to stall across multiple continents. While 20th century power was defined by oil reserves and territorial expanse, 21st century influence is increasingly measured by a nation's access to these microscopic wafers. Though the design of this hardware is global, the physical manufacturing process has become centralized in one of the most concentrated ecosystems in industrial history. This chart shows the global semiconductor foundry market share as of late 2023. A single firm, Taiwan Semiconductor Manufacturing Company, or TSMC, accounts for over 60% of total global revenue. That dominance increases to 90% when looking exclusively at the most advanced logic chips, the kind required for high-end artificial intelligence and sophisticated military hardware. The physical epicenter of this supply chain is the Hsinchu Science Park in Taiwan, where these massive fabrication plants operate around the clock. This concentration means the engine of the global economy sits on a self-governed island claimed by the People's Republic of China, placing the world's most critical technology directly on a geopolitical fault line. Semiconductor innovation began with American dominance, following the invention of the transistor at Bell Labs in 1947. For decades, the companies that designed the chips also owned the factories that built them. That dynamic shifted in 1987 when Morris Chang founded TSMC in Taiwan, introducing a business model that would decouple design from manufacturing. Known as the pure play foundry, this model meant TSMC would not design its own chips. Instead, it would act as a high-tech factory for hire, allowing companies like Apple and Nvidia to focus on architecture while outsourcing the actual fabrication. This strategy allowed Western tech giants to scale rapidly, but it also resulted in the centralization of global manufacturing leverage into a handful of vulnerable locations in Asia. TSMC's ability to produce advanced chips depends on another irreplaceable node, a Dutch company called ASML. ASML alone builds extreme ultraviolet lithography machines. High-powered lasers strike molten tin, creating light to carve silicon circuits. This technology took 20 years and billions of dollars. Each bus-sized machine contains thousands of components and costs upwards of $200 million. Without access to these specific Dutch machines, a nation is physically unable to manufacture the advanced chips required for modern military modernization and artificial intelligence. This timeline shows how quickly the semiconductor industry has escalated into a diplomatic battlefield, shifting from trade disputes to the explicit use of export controls for national security. The United States responded with the CHIPS Act, a $52 billion federal investment, reshoring advanced manufacturing to domestic sites in Arizona, Texas, and Ohio. Simultaneously, the U.S. implemented stringent controls to deny China access to the most sophisticated AI chips and the equipment needed to make them. This chart shows the scale of China's counteroffensive. Through its Big Fund, Beijing has committed tens of billions of dollars to achieve domestic semiconductor self-sufficiency and bypass Western sanctions. Despite these sanctions, China's SMIC recently demonstrated the ability to produce 7-nanometer class chips by reconfiguring older generations of manufacturing equipment. This capability was proven to the world when these advanced chips appeared in the latest Huawei smartphones, signaling that the technological gap may be closing. The semiconductor ecosystem is no longer governed by market demand alone. It has become a tool of national security and economic denial. This concentration of industry serves as Taiwan's silicon shield, the theory that the island is so vital to the global economy that the West would be forced to intervene in the event of an invasion. However, as the US and Europe build their own foundries to reduce their dependence on Asia, Taiwan faces a paradox. Its success in diversifying the supply chain may eventually reduce its own strategic indispensability. In a scenario where Taiwan is physically blockaded, the flow of raw materials in and finished chips out would cease. The resulting shortage would affect every sector from healthcare to heavy industry, likely triggering a global economic recession. We may also see a splinter net of silicon, where export controls lead to two separate technological spheres, one using Western standards and another dominated by Chinese legacy chips, used in everything from cars to home appliances. As artificial intelligence requires more processing power and modern militaries rely on smarter munitions, the competition between superpowers will be decided by these microscopic architectures. In the 21st century, the path to global influence